Imagine a creature small enough to sit in the palm of your hand, lifting an object 100 times its own weight off the ground. If a human adult possessed that exact same strength ratio, they could lift a fully loaded semi-truck without breaking a sweat. This is the Hercules beetle. Found across Central and South America, it stands out with a bright yellow spotted shell and massive horns. This strength evolved as a specialized survival tool. It provides the mechanical leverage required to navigate a habitat where every inch of terrain is an obstacle. The rainforest canopy gets all the attention, but the most intense physical challenges are found on the forest floor, a dark, humid world choked with dense roots, decaying wood, and fallen leaves. Navigating this tangled understory requires massive scale. Adult male Hercules beetles can grow up to 7 inches long, making them one of the largest flying insects on the planet. They are encased in a thick, shiny exoskeleton. This heavy biological armor protects them from the constant moisture, rough terrain, and sharp debris of the jungle floor. Combined with heavy plating, the beetle is uniquely equipped to bulldoze through a habitat that would stop smaller insects dead in their tracks. During the rainy mating season, that physical strength is put to the test. A male navigating a fallen log will often cross paths with a rival, sparking an intense territorial dispute. The beetles settle these disputes with 2 prominent weapons, the cephalic horn, which extends from the head, and the longer thoracic horn, which grows from the center of the body. Together, these horns act like a giant serrated claw. The 2 males lock their weapons together, pushing and shoving in a desperate struggle to gain leverage over their opponent. When one male finally secures a tight grip, he uses his extreme strength to lift his rival completely off the ground and throws him off the log. These intimidating weapons and all that immense lifting power evolved for reproductive competition and territory defense. They aren't used for hunting prey. After surviving a grueling wrestling match, the victorious beetle needs to replenish his energy reserves quickly. You might expect a creature that looks like a heavily armored gladiator to be an aggressive predator. Instead, the adult Hercules beetle eats a diet composed entirely of rotting tropical fruit and tree sap. When he locates a falling mango or banana, he uses specialized chewing mouth parts to pierce the tough outer skin, slowly masticating the decaying flesh into a soft, easily digestible pulp. Underneath the warlike exterior, the Hercules beetle is a gentle herbivore, sustained entirely by the natural decay of the forest around it. The beetle's connection to that decay starts long before it grows those massive horns. Its life begins hidden deep inside a rotting log. For 12 to 18 months, the insect exists as a pale, massive grub. In this larval stage, it does almost nothing but consume decaying wood, growing to weigh up to 140 grams. Once it reaches maximum size, the grub burrows into the surrounding soil. It creates a hollow pupal chamber, where over 2 to 3 months, its body transforms and those signature horns finally develop. Even after breaking out of its pupal casing, the adult stays buried underground for several more weeks. It has to wait for its soft, newly formed exoskeleton to fully harden into armor. The beetle spends over a year and a half hidden in the dark, constantly consuming resources, all to prepare for an adult life that only lasts a few short months. During those adult months, the rainforest environment dictates the beetle's every move. When a wave of dense, humid mist rolls through the understory, a rapid biological reaction takes place. The beetle's bright olive-green shell reacts to the moisture in the air, quickly darkening until it turns a stark, solid black. This diagram shows a microscopic cross-section of the beetle's exoskeleton. The shell is full of tiny, spongy pockets. As humidity rises, these pockets fill with water droplets. This alters the light refraction, the angle at which incoming light bounces off the shell, changing the color we see. This rapid color change physically links the insect to the daily weather patterns of the jungle, turning it into a living, breathing barometer of the rainforest's humidity. Zooming out from the individual insect reveals a much larger biological mechanism at work across the entire forest. This chart maps nutrient cycling. By eating dead logs as a larva and rotting fruit as an adult, The Hercules beetle breaks down organic matter. This relentless consumption creates nutrient-rich soil, directly fueling the growth of new trees and flowers. This recycling process is the beetle's most critical ecological contribution. By converting rot into nutrient-dense soil, the insect provides the foundation for the entire rainforest to regenerate. But that cycle is easily broken. The primary external threat to this fragile ecosystem is widespread habitat destruction and deforestation caused by human activity. When the rainforest is cleared, the continuous supply of decaying wood and fallen fruit disappears. Without those basic building blocks, the Hercules beetle cannot survive or reproduce. The biome is deeply interconnected. By protecting the towering rainforest canopy, we safeguard the damp, rotting floor below, saving the essential home of the beetle and thousands of other unique creatures. The strongest forces in nature are often the smallest. By maintaining our curiosity about the hidden lives on the forest floor, we take the first critical step toward protecting them.